Okay, great. As Jason mentioned, I'm Henry. I'm one of the co-founders of Snorkel AI. I'm really excited to be talking to you all here today a bit about how we accelerate AI and NLP development in finance. Some of our earliest customers at Snorkel were in the financial sector. And they kind of thinking through how they solve problems has really shaped the way that we've thought about building the product, how we deliver end-to-end solutions. And so it's been amazing to see where kind of that learning has taken us. Now, today, we're lucky enough to be working with at least 5 of the top 10 US banks, several more around the world as well. And so super excited to, again, share some more of what we've learned, take a look at some case studies at the end, and the core technology that we're building. But I actually want to start with something outside of the world of finance, and actually in the world of healthcare. This will all tie back, though. Don't worry. Awesome. Okay. So this is actually some work from some of our collaborators from Stanford Hospital, back kind of from the where Stanford or Snorkel started as a research project. This paper that they published in JAMA ended up creating some pretty sensational, like BuzzFeedy like headlines. Always like looking at the primary research, though, as a kind of technology and research person myself. So let's look at this slightly more boring headline. And I can read it for folks in the back. Geographic distribution of US cohorts used to train deep learning algorithms. The punchline of this work, sensational headlines aside, is that the vast majority of data used to train AI systems for healthcare use cases in the United States comes from just 3 states: California, Massachusetts, and New York. Normally, I think someone in my shoes would take this opportunity to make a joke at the expense of that like specific collection of 3 states. I don't know how well that lands internationally. I've also been a permanent resident of all 3, so I'm gonna maybe skip the joke. But jokes or non-jokes aside, right, this fact should be pretty troubling. The idea that so many systems are built on such a biased subsample of data from very specific medical systems and very specific geographic locations means that, hey, look, you know, as I'm sure everyone in this room would expect, the outcomes of those systems can lead to significant risk and bias when actually put into production, right? That ranges from tools that might misdiagnose patients based on skin tone, or predictive systems for billing that have borderline discriminatory behavior when acting on people who are outside of those regions where the data was collected from. So now the obvious question is why, right? Why are systems built primarily using data from only 3 states? The big picture is that even if you have access to raw data from outside of those systems, it's just not ready for AI usage, right? It takes massive effort to operationalize data from raw medical records or whatever else you're looking at to be ready to be fed into an AI algorithm to build a system on. And that is really kind of the punchline both of this piece and of the presentation as a whole today. Again, there just really wasn't as much data or nearly any that was AI ready, easily accessible outside of those states. And so, really quickly, what does it mean for data to be AI ready, right? First, it has to be available in a format and processed in a format that can be fed into, say, a machine learning algorithm, something that can go from, raw format to something that's machine processable. And second, very, very critically, it has to be labeled or annotated by experts in a structured way to provide those critical training data labels for AI systems, right? More on that in a bit. Okay, but thankfully, very thankfully, this is the only instance in known history of an AI system doing the wrong thing because it was built on top of the wrong data. So thankfully, total anomaly here. Oh. Maybe not, right? So I'm sure we've all seen so many of these headlines from just about every single industry where something has gone awry because, hey, we took whatever data we had available in an AI-ready format, shoved it into our machine learning algorithm, built it, hey, looks like it tested pretty well against our test data, and then let's ship that thing to production, only to find out that there are significant adverse effects when actually deployed in the real world, right? We see a number of industries represented here. Of course, finance is no exception to this. Again, seeing how the impact of using a limited subset of data, a biased data sample, to train systems to make or for loan decisioning or credit can have adverse effects on underrepresented populations when it came to the data that was actually used to build those systems. Again, every single industry that we see has a massive need to build more reliable and more repeatable processes to get data AI ready, right? Again, those two really critical pieces, structuring it, processing it in a way that you can feed into an algorithm, and second, really critically, providing high quality labels to actually train your systems. Again, you can see it in the headlines. You can see this in talking to the folks that we do every single day, working across industries like healthcare, telco, retail, and of course, finance as well, as I mentioned. Every single one faces very unique challenges in repeatably operationalizing data for AI use cases. And as I'm sure you're all familiar, finance has some very unique challenges in making data AI ready, right? So just touching on a few of them here. There's lots of data available in a semi-structured or unstructured form, right? Think conversational transcripts between banking customers and agents. Think multi-hundred-page PDF syndicated loan documents, for example. Transactional data, of course, as well. So again, lots of raw data available, but not in a structured form, again, that I can easily plug into an algorithm, right? So we need to structure it and make sense of it first. Of course, data in the finance world is extremely sensitive, right? I generally can't send it externally due to either kind of institutional or legal regulations. Even if I can send it externally, usually the people that should be looking at it to provide high quality labels for training systems should be in-house subject matter experts, right? They just know the specific data that I'm working with. They know the specific processes of my financial institution, and their time is extremely valuable, extremely rare, right? So, hey, that limited time being used to get data AI ready, it's an extremely high opportunity cost for them. And all these factors combine to create scenarios where, hey, the data that I'm using to develop AI systems may just not be representative of the population as a whole. Again, just kind of a repeat of that very first headline that I showed, right? Working with a small bias subsample, even if I'm not aware of it, again, just because I didn't have repeatable processes for getting data AI ready. Awesome. So zooming out, there are trends here that impact every single industry, right? The vast majority of data that all enterprises, all organizations that we work with, that they want to use for AI initiatives, 85% of it, by some estimates, is unstructured and unlabeled, right? Again, not ready for AI usage. It forms what we like to think of this iceberg under the surface of extremely valuable data, if I can operationalize it. Again, think of the multi-hundred-page PDF contracts that we have available, conversational data between real people, customers, and agents, transactional data, everything that news data or news articles even, everything that I have available. Again, extremely high potential if I can operationalize it for AI usage, but the tools just aren't there for most organizations to, again, repeatably get data ready for AI usage. What we find is that data science teams find themselves relying on extremely manual approaches to get data ready for AI usage. The biggest bottleneck in that process is typically manual data labeling. So that, again, that looks like either asking internal subject matter experts to go through thousands or millions of records, manually annotating each one with the right output that they want the machine learning algorithm to learn to replicate. Again, that can be extremely slow given the limited availability of subject matter experts and extremely high opportunity costs. These are people who are experts in your financial institution's internal processes, operations, the actual subject matter that they're working with, in loan contracts or whatever else that might be, right? Extremely high opportunity cost for them to spend their time, again, manually annotating thousands or millions of records, right? In some cases, you can send it externally to, say, crowdsourcing services, but in many of the financial institutions that we work with, it's just a total non-starter, either due to privacy constraints, right? I just cannot send my data externally, or because the folks that are doing the labeling on those crowd-working services just don't have the subject matter expertise to provide high-quality labels repeatably that I can use to train my ML systems. And now getting into kind of a little bit more of how we think about the entire kind of ML lifecycle, as Olga was just talking about, even if I do manage to scrap together an initial training set to build my ML model, right, the job isn't done. My model may not be performing well, my data distribution might shift, my modeling objectives might change, right? Maybe the business comes to me and says, oh, hey, sorry, we were trying to classify those contracts into one of 4 classes before. Actually, what we need downstream is to know whether it's one of 8 classes. All of these types of things necessitate an extremely expensive manual relabeling process where I have to basically go back to the start, ask my experts to label my data all over again, incur potentially this cost of weeks, months of time, and again, extremely high internal opportunity costs to rebuild my training data from scratch, to try training my model again, and deal with this ongoing cycle as I ship models to production and kind of learn more about what's needed by the business or its performance in real-world settings. Okay, so hopefully I've convinced you that this old-fashioned way of getting data labeled, getting data ready for AI usage is a major bottleneck and really not scalable, right? For many of you, I'm sure absolutely no convincing was needed. This is something that you deal with every day, right? How do I get my hands on high quality and in large enough quantity data that's ready for AI usage? So, big like Shark Tank moment, what if there was a different way to go about doing this? And so we'll start by talking about an approach that we've been working on for years for getting data ready for AI usage, as kind of I've spoiled up here on the screen, programmatic labeling, right? Again, this is an idea that takes advantage really critically of that exact same expertise that I was using to label data, but that allows me to label data at machine speed, right, in seconds, minutes, or hours, even for thousands, tens of thousands, hundreds of thousands, or millions of records, rather than in human time, which could take weeks or months and has extremely high opportunity cost. So let's talk about programmatic labeling, and it's often easiest to start with an example, so let's go ahead and do that, right? So in this example, I might be trying to build a system that can identify whether, say, loan contracts have an interest floor rate, for example, extremely relevant when it came to transitioning away from LIBOR or anomalies when it comes to interest rates, like heading negative. So a really simple example here. Rather than going through the thousands and thousands of contracts myself that I might need to label to build an AI system, I instead kind of express what I would be looking for when I am manually labeling data directly to the system. So that might be just a really simple regular expression pattern, like if I see deemed to be 0, either spelled out or the number 0, then label the document as having a floor rate, right? Because this is encoded programmatically, I can now go run it on thousands, tens of thousands, hundreds of thousands, millions of contracts potentially at machine speed rather than having to go through each and every one of those manually. And that's really the key idea here, right? When we ask subject matter experts to label data manually, they look at the data, decide what the label should be, and then discard their reasoning entirely, right? In this programmatic labeling process, instead what they do is they encode that reasoning as a simple function, like the one that we just saw, and there's the example there. And I do this maybe dozens of times, expressing kind of different patterns, different insights that I'd be looking for, and lots of other ways to do this as well. And then these labeling functions, as we call them, can go off and again label data at machine speed, seconds, minutes, hours, rather than taking weeks or months of time for manual labeling. Really key other benefits here, including inspectability, auditability, if I have enough time, can talk about how that factors into things like model risk management processes, where I can actually just go back and inspect, audit what labeled my input data, rather than having to guess what was in a subject matter expert's head when they were labeling data manually instead. Awesome. So this, as I mentioned, this idea of programmatic labeling, it's an extremely general and very powerful paradigm, right? So Snorkel Flow, our product, and I'll get into this a little bit more, can bring together, manage everything that you have to bear when it comes to organizational resources for labeling data, right? From old manual labels I might have sitting around to patterns from subject matter experts like I showed, lookups against ontologies or knowledge bases. You can incorporate old rule-based systems, and increasingly we're building in automated technologies into the product itself to kind of automatically mine your data, look for patterns that you can use for labeling, and then even kind of bring in the latest and greatest in terms of large language models to be able to identify patterns for you. As I'm sure you've all seen, or likely many of you, just kind of applying those to proprietary data sets like you often see in the financial sector. Things don't work very well out of the box, but you can use the knowledge that's encoded in things like large language models to go through this labeling process more effectively. And I can talk about that a little bit at the end. Ask me a question, whatever we have time for. Okay. Of course, though, these labeling functions that I write, they're not going to be perfectly accurate, right? If I were, I would just build a rule-based system and everything would be good. So how do we go about reconciling the potentially very noisy, potentially very imprecise or conflicting labeling functions? And this is where we've done years of work on the algorithmic side, first at Stanford and again now at the company, again on how to aggregate and denoise these signals. I'm not going to bore you with details, but if you're interested in the technical stuff, either come find me. You can also go check out our website. We have a lot of different case studies of how kind of marrying this rule and high precision system building approach in the labeling process with the generalization techniques of modern machine learning leads to really kind of outstanding results without having to spend extremely valuable expert time on labeling data and without having to delay development until you have a large enough training data set. Awesome. So it turns out that this approach to labeling unlocks a whole new workflow for AI and NLP development, and we call this data-centric AI, right? The idea that we should be building workflows and interfaces to engineer the training data that goes into these systems directly, whereas many tools that have been built today primarily just focus on the model. How do I tweak and tune the model rather than addressing kind of the fundamental question, giving people, again, those workflows, interfaces to engineer the data that goes into those models directly. This is something that we've been working for years now. Again, I mentioned first at Stanford, now at the company. We have over 65 papers published on Snorkel technology. Encourage you to read maybe 0 of those. Much better summaries on the website. Those are extremely boring. But again, come talk to me if you want to hear about the technical details. And again, this general idea of shifting from model-centric AI, where you're focused on tweaking and tuning the models because those are the tools that you have at your disposal, to giving people those workflows, those interfaces to engineer the data that goes into these systems directly. We're bringing this all to life in our platform, Snorkel Flow. AI development platform that's built to help data science teams develop high-quality training data sets really quickly, and primarily through this approach of programmatic labeling, where you can build those training sets 10 to 100x faster than if you were using manual labeling alone. Again, you can find out more on our website here, or we have a demo booth set up over there. Here's a quick snapshot from our product. We give you this kind of IDE-like experience for building training data sets, building models where I can really directly, again, engineer the training data, the labels that I'm building, get feedback based on the models that I'm training really quickly, and use this to create this much more iterative approach to ML development here. There are a wide variety of other benefits that this data-centric workflow brings about. One really important one that we see in the financial world is bringing together subject matter experts and data scientists. Many teams that we work with have found themselves primarily, collaborating with subject matter experts by emailing Excel spreadsheets back and forth to where you get data annotated _ final V2, and there's this 100 email long thread. It's a really error-prone and not very efficient way to collaborate with those critical subject matter experts. So instead, having this interface, this platform where you can collaborate really directly, subject matter experts can provide insights, data scientists can drive the modeling process, and everyone can kind of audit and review results has been really important to speeding things up. Okay, I'm going to go through a couple of customer stories really quickly, focused on the world of finance. Again, plenty more on the website. Encourage you all to check those out. This first one is from a top 3 US bank, actually similar to that example of a labeling function that I showed earlier, where they were trying to identify and triage risk exposure within their loan portfolio fast in response to some rapidly changing interest rates. And so, yeah, we can talk about this really quickly. Cool. So in previous use cases where they're, say, trying to build kind of an extraction model to pull out specific clauses or pieces of information from loan documents, previously they were finding themselves spending 6 person-months of time on manual labeling, again, from subject matter experts, before they could even start building a model, right? So right off the, out the gate, right, if that's 3 people doing the labeling almost full time, that's like two months of time before you can even start the labeling or the modeling process. Modeling, actually relatively straightforward, right? The tools are available there, and they were able to use an open source model, train it within a day to get an initial model built once they had the training data available. They had to go through building an ad hoc error analysis process, but the most costly kind of step after building that initial training data step was actually going through relabeling, again, due to kind of shifting goals of the business. They were interested in extracting kind of 2 additional types of clauses before this thing was ready to go to production. So already, right, they have to go kind of bear this expense again and wait kind of another few months before they were able to start rebuilding their models to meet the new needs of the business. But using Snorkel Flow to tackle kind of a similar use case, they were able to build a training data set of over 250,000 labeled loan contracts in under 24 hours. Again, this involved just kind of a sit-down session between data scientists, subject matter experts, where they could collaborate, figure out signals that they wanted to use for labeling, go through the modeling process directly in Snorkel Flow, use the auto-generated error analyses, and actually had to adapt the training data set to meet some new objectives for the business. Again, they wanted to extract additional clauses, and that was all done through just kind of simple code edits to the labeling functions that they had written. Could then press the big relabel button, and again, that gets done at machine speed in just a few minutes. So they can really rapidly iterate, go from scratch raw data in a business objective to a model that's been built and verified in under 24 hours. I've seen this across industry, lots of different use cases you can take a look at, lots of different ones that we support in the financial services through kind of how we let people work on a variety of different data types like text documents, PDF data, conversational data, and a variety of other ML tasks as well. So document classification, information extraction, utterance classification, a wide variety of things that we've seen put to work in the financial sector. Just a few kind of example use cases from AML, KYC types of things, news analytics, credit spreading, again, all can be tackled using those set of use cases that we have, again, providing those workflows for people to get data ready for AI usage quickly, no matter kind of what the ML task type or the data type they're looking at is. I'll go through one more super quickly. This was a KYC use case where previously they were having a number of analysts at the bank, hundreds of them actually, looking through 10,000, this is a little bit confusing, 10,000 10K reports per year, each one taking around 30 to 90 minutes of manual review time to pull out the information that they needed to. So the input that they were looking to build an automated system to help with this process meant, hey, we're putting in kind of raw PDF documents representing 10K reports, and we want to build models to be able to pull out kind of a variety of different entities. So maybe the company, the nature of the business, et cetera, et cetera. Again, that was all done manually before, but using Snorkel Flow, they were able to build models that kind of average across the board over 90% accuracy. We're able to save, again, very confusing, 10,000 person hours per year, which they estimate around $500,000 in savings from the initial deployment of this model. And they were able to build this entire thing from scratch without pre-labeled training data in just 8 weeks. So again, lots more examples. Booth number, forget that. You can just find the big Snorkel logo over on the right-hand side. But that's all I have for you today. Thank you again, everyone. It was great to be here and happy to chat with folks afterwards as well.